Hello, this is how to determine if a KDE application is using primarily Qt Widgets or QML. This is the list of KDE applications, apps.kde.org. They're sorted by default descending by popularity, which means that Ocular is the most popular KDE application. I'm not sure how the statistics are being computed. Let's look at some of these applications and determine if the application is using Qt Widgets or QML, QQC2, Qt Quick Controls 2. This is Ocular, the PDF viewer application. Let's see. The application is already installed. This is how it looks by default. There's a main toolbar. I right-click on the toolbar and I immediately see familiar things. The fact that I can unlock the toolbar, the fact, let's open a PDF file. I have downloaded from the internet a random PDF file and I have opened it in Ocular, the PDF viewer. So I can move the main toolbar wherever I want, including at the bottom of the window. I can lock it back, lock toolbar positions. This makes it not easy to move around because it hides these two vertical bars that you can use in order to grab the toolbar. So this to me says that it's using probably using Qt Widgets, and it's probably using kxmlgui for the main menu structure and for the main toolbar and the actions behind the menu items and the toolbar buttons. You can add many other buttons to the toolbar. Let's see that. So there's 4 different toolbars. Some come from the host window, and then there's plugins that will be shown inside this window, such as the Ocular part. Let's put a About KDE button. Let's see how we do that. Okay, that's interesting. So there are 2 main toolbars. One is the Ocular shell and the other one is the main toolbar, and they are merged. So I placed the About KDE button on the wrong toolbar. Let's get it back. It should have went towards the main toolbar Ocular part, not Ocular shell. But this action is not available here. Okay, that's interesting. This is then the only option. And there's a defaults button to reset everything to the default settings. You can change how text and buttons work. You can go icons only. You can change the size of the icons. Let's see how we get everything back. I'm not sure how to reset the text position and icon size. So configure toolbars only resets the buttons that are being shown in the various toolbars. So Ocular Shell had 0 buttons, main toolbar did not have, had only these default buttons. So it was text alongside icons. Some buttons will have text shown, other buttons will not have text shown. If you want to have the text visible near the button all of the time, you should go text under icons. So all buttons now have text, whereas when you go text position, text alongside icons, only some icons, only some buttons will have the text visible by default. For instance, zoom out and zoom in is not visible by default. And then icon size, default. But let's actually prove that Ocular is using Qt Widgets. For this, we're going to use the graphical user interface Qt Inspector application. Let's get a terminal and install. The application is called gammaray. It's already installed, but you would install it as you would expect. My Linux operating system is Ubuntu 25.04. Let's start gammaray. And we want to connect to Ocular. There's just one process, /usr/bin/ocular. Attach. And now we have side by side the Ocular application while it's running. And then while the application is running, the application gammaray, which is a runtime inspector of Qt applications, is inspecting the running application. So we can see live inside the Ocular application, we can see the various buttons, the text, the menu structure, etc. We can inspect those inside the Widgets tab in gammaray. Okay, so we can see there's an Ocular shell. Let's make the zoom a bit smaller. And let's inspect, for instance, the view mode button. The pick element button. So on the right hand side of the fit width, this guy. So it's a Q tool button. It's a K toolbar, Q widget. So all of these are Qt widgets. The shell, the Q widget, the K toolbar, the Q menu, etc. And they are Qt widgets because we can see them inside gammaray in the widgets tab. The QML graphical user interface controls inside of an application. When you inspect that application using gammaray, you will see them in the gammaray tab for QML objects, which is called, where is it? I don't see it in here. Let's open a Qt Widgets application, a QML application, and inspect it using gammaray, and we'll see probably the tab appearing inside gammaray. So we're going to close gammaray. Gammaray tends to not behave as correctly as possible. So be patient, restart gammaray as many times as needed. Let's look at an application that we know does contain QML controls. This is FileLight. Let's install it. It's already installed. Let's launch it. And let's have it compute the chart for a directory. I am using the ~/downloads directory. Okay, so immediately we can see that the main toolbar does not look the way we know. There's no context menus anywhere. Let's inspect the application using gammaray. File light. Okay. I could see in gammaray a ton of QML objects, but then I couldn't inspect them visually the way I expected. And now if I look at the deb package provided by Ubuntu for gammaray, I can see this interesting deb package, gammaray plugin quick inspector. Maybe the QML inspector was split out of gammaray as a different deb package. So we'll install this deb package. I'm not sure why would you split core functionality out of the gammaray application just in order to create an extremely small 376 kilobyte deb package. Okay, back to where we were. Gammaray. Select file light. And now we have a new tab inside gammaray which is called Quick Scenes. We can see that most of the application is QML because it appears in the Quick Scenes tab in gammaray. There's a root item at the top. There's a list of packages. There's a toolbar. There's a list view, etc. And you can inspect the items. Let's do that. Let's inspect the chart. Okay, so the chart is I'm not sure what. Inside a row layout, inside the map page, there's a shader effect source. But map page does sound like... No. Okay, can we pick something else? What did we pick? So we picked the label 69.8 megabyte, which is the size of the Qt Online installer. Okay, it's a Q quick text. There's a subtitle and a label, and they're grouped together in a QML item named title subtitle, which is probably declared in a title subtitle.qml file. Apart from this, from the fact that we can see the majority of the graphical user interface objects appear in quick scenes, we can see that in Widgets tab inside gammaray, there's just menus. There's a home folder, root folder, quit. This looks like the file menu, configure menu, and help menu. I'm not sure how to trigger those menus. Okay. So again, gammaray will do things like this. So it's not a problem. You just restart everything. Be glad that gammaray does exist and it works correctly while it works. If it crashes, well, that's it. And if we walk through the other tabs inside gammaray, we can see a ton of QML, QQuick references. We can see in here KQuick style, Qt quick layouts, row layout, KQuick style item, QQ item. At models, we can see Qt QML models list model. In objects, very many objects of type QQuick something, context, item layer, anchors, etc. Okay, and we inspected the application FileLight. We saw that it doesn't really resemble a classic KDE application from the structure of a classic KDE application from 20 years ago, in the sense that the main toolbar doesn't seem to be movable around, doesn't seem to have a context menu. You probably cannot easily change the text alongside icons, text under icons, icon size for the main toolbar. So there's a main toolbar, there are buttons, but you don't get the flexibility that you get by default with most Qt Widgets KDE applications which use kxmlgui. There isn't even a main menu, so there is no help about KDE item. It's just these three buttons, 3 dots button with more actions where you can open the About panel. And this About panel is not a window, a pop-up window like this. You need to navigate back. And there are no two different abouts, one about the KDE community and one about the application itself. There's just one about the application. And the various QML, Qt KDE applications tend to look a bit different. Have various different items in the more actions button menu, have the main toolbar look differently. Sometimes there's a splitter in here. Let's open some other QML applications and see how they're different. Let's find the next most popular QML application, Plasma System Monitor. I'm on X11 and still the application Discover is not raised when I want it to be shown. It just stays minimized in the toolbar, in the main KDE panel. The icons only task manager, and it's not brought to forward. Launch. Okay, so again, no main menu, no kxmlgui style toolbar. There's actually two different toolbars, the one that's before this splitter and then the others that are after this vertical splitter. The more actions button has a different icon. In system monitor, it's a hamburger menu icon, whereas in FileLight, it's a 3 dots icon. And we can see also in apps.key.org, there's a mixture of these two icons. There's an icon with two horizontal lines and 3 horizontal dots. This is neither a hamburger menu icon, nor a 3 dots button. But in here we have two abouts. There's about KDE community and about the application, which means that FileLight is missing the about the KDE community item action in this more actions menu. At least the tooltip is the same, more actions with uppercase M, uppercase A. I'm not sure where the quit button is in FileLight. Okay. So no main menu. The toolbar, you cannot right click on the main toolbar. Let's inspect it a bit in gammaray. What's the name? Plasma System Monitor. Okay, widgets. There's just some context menus. Or no, it's just menus. And everything else, all of the other graphical user interface objects are QML. Maybe this context menu is messing up. That was the issue. I have started editing the system monitor because system monitor is a dashboard style application which has a default layout, but then users are welcome to shape the dashboard as they see fit. They can add more widgets, resize widgets, change colors, etc., which is this edit page button. Okay, we don't actually want to edit the dashboard, so discard changes. And back to gammaray. Sometimes the application that's inspected behaves wrongly because it's injected by and controlled by gammaray. Sometimes gammaray behaves incorrectly because you did something that it doesn't like inside the application that's being monitored by gammaray. So the fact that I had a context menu displayed in system monitor, then gammaray could not inspect the graphical user interface and it crashed. Okay, so everything is a quick scene in here, a QML object. There's a root item. There's various pages. Let's look at one of these, hopefully, buttons. Processes. So processes is a text, a quick mnemonic label. There's an icon. And there's a Kirigami icon in here. So the application is actually using the KDE library framework for QML, which is Kirigami. Kirigami is for creating applications which work correctly both on Android, on a phone form factor, but also on mobile devices, phones running, for instance, KDE Plasma, mobile shell, but also on the desktop. How these things work is that in Qt there's QML, which is a programming language and a display technology that struggles to be as fast as possible to run on systems with very few resources, on automobile dashboards, on in-flight entertainments in airplanes, etc. And then there's QQC2, QML Qt Quick Controls version 2, which using QML, so QML is about geometric shapes. There's rectangles and colors and labels. And QQC2 on top of this brings graphical user interface controls that you would use in a desktop application, such as buttons and menus and context menus, etc. And QML, the QML framework Kirigami from KDE is extending QQC2 with technologies that are related to KDE, such as icon themes, KDE-specific theming for QML, font technology, such that the application looks as correct as possible inside when running inside the KDE Plasma desktop. And not only. Okay, so we can see very few Qt Widgets objects. We can see a ton of QML objects in the graphical user interface objects of System Monitor. And then if we browse the other types of resources, we also can see various QML Qt Quick types and objects. QML microphone permission. Applications that use QML that are created by the KDE community often will have the graphical user interface written in QML language, so in files with extension .qml, whereas the functionality behind the implementation of graphical user interface events, for instance, the background services, the meat of the application will be, the backend will be written in C++. And the communication between the graphical user interface that's written in QML and the rest of the application that's written in C++ will often involve models. In this case, we can see very many models, 50. Or KDE ksysguard.page/page data model, legend model, tools model. Okay, let's look at some other applications. Arc decompression algorithm, decompression application, the zip unzip application, console the terminal, Dolphin the file manager, Kate the text editor. These use Qt widgets. And we can see them behaving similarly. Some of the Qt widgets applications do have the main menu hidden, but you can show it with Ctrl-M or Ctrl-Shift-M. But the main menu is there. There's a main toolbar that you can edit as you would expect. Let's show it also for console. How do we show it? Settings toolbar, shown main toolbar. Right click and make the icons huge. Let's see a couple more applications and decide if they're using Qt widgets or QML. Discover the App Store. Install on Linux. This will be fun. It's going to open the App Store Discover and ask it to install itself. Okay. Again, no main menu. The main toolbar is not editable. I'm not sure where the About KDE functionality is. I can see the About application functionality. It's just visible out of the box in the left-hand side tree view. So it does smell like a Kirigami QML application. Let's prove that using gammaray. How do we get to discover? Plasma discover this guy. Okay. Widgets. No remote view available. Oh. Quick scenes and everything is a quick scene. Inspect, donate, label, and it works correctly. Kirigami icon. Label. %. Quick layout, column layout. It's interesting that gammaray allows you to inspect deep inside a QML control. The actual type of this item is probably, I don't know, Kirigami icon or something, but then inside there's a ton more QML applications and you can inspect all the way down using gammaray. You can see the styles that are being applied, the fact that there's a column layout hidden somewhere. Rectangle. So rectangle is a basic QML type. It's a geometric shape. Also in signals, you can see a ton of activity when you actually use the application. Wow. And I'm going to crash the application again, gammaray. But you can see that the signals are related to QQuick and QML. And the resources will contain JavaScript files, QML files, the built-in QML themes from the Qt framework, Max Style, Fusion, Common, shaders, this is an icon theme, and many QML files. Okay, so that was it. This is how you install a KDE application and find out if it's using Qt widgets or not. By inspecting the application, by looking at the application, does it have a main menu? Is the main menu hidden? Is there a main toolbar? Is the main toolbar hidden? Is the main toolbar editable? Can you add and remove actions in the main toolbar? Can you move around the main toolbar? Can you lock it down or not? If there's a main menu, does the main menu have the structure that you would expect from a KDE kxmlgui application? Does it have two about boxes in the help main menu item? Okay, that would indicate a Qt Widgets application. QML applications will look different from Qt Widgets applications, but also QML applications tend to look different between QML applications. In order to make extra sure, you can inspect using the application gammaray. Make sure you install the QML inspector plugin on the Debian family of Linux operating systems. But other than that, you can inspect the source code of the application to decide if it's using QML or not. Let's pick an application that is not using QML and one that's using QML. And let's have the source code side by side. Right-click, browse source code for each. Let's look at the structure of directories. There's an src directory. And the src directory has a QML directory, and in here there's tens of .qml files. So this is a QML application. Might use QQuick controls too. It certainly does this thing. It certainly uses the base QQuick QML, the geometric shapes, and it might or not use Kirigami or Kirigami add-ons, the two libraries frameworks from the KDE community. Kirigami doesn't depend on KDE technologies. Kirigami add-ons does depend on KDE technologies. Okay, so the other application, Color Paint, doesn't have any QML directory. We can also probably see in the cmake list.txt, the top level one. How do we do that? The source code of most KDE applications will have a top level cmake list.txt file. And in here you can search for things like QML, quick controls. You can see all three of them for Haruna, the video player. For color paint, let's search for QML. No. For quick, no. For controls, nothing. For Kirigami, whereas Haruna does use Kirigami. And then some Qt Quick applications will use kxmlgui, this guy, and some will have .ui files, so files with extension .ui. I cannot find any file with extension .ui in Color Paint. You can specify the structure of graphical user interface windows using Qt Widgets, either straight in C++ source code, where you go create new widget, create new toolbar, create new button, etc. in source code, or you could use the native Qt format with files with extension.ui, which is a XML file format that you can edit using a designer application from the Qt framework, a graphical user interface application that allows you to move around buttons, add a new group box to the form, etc. So a forms editor. So this is it. Thank you.